we will learn a very important concept of computer science called the recursion. And first, the very simple concept that what we concept of recursion, that what do we mean by recursion and how actually it is or we define recursively the functions, sets, sequences. Today we will read that thing, and slowly then we will be going to that how recursion is used to define relation, how to solve, etc. So, today we will read that recursion. Now, sometimes it is difficult to define an object explicitly. So, we can write that sometimes it is difficult to define an object explicitly, but it is easy to define in terms of itself. And this process of defining the object in terms of itself is called recursion. So, very simple way if I told that this process of defining is called recursion. Now, recursion normally we use to define the sequences, the functions, the sets, and later we will use for many real life problems. So, I can write to define sequences, functions and sets. These are the three basic things. We will see that how recursion is used. Now, we take one simple example to illustrate the concept of this recursion. We take one example. Okay. We define a sequence of power of 2. How I write? Say I give a sequence a n equal to 2 to the power n. Now, this the same sequence, since it is power of 2, I can define in a different way, but I need some initial value. So, what is initial value? Say for n equal to 0, I say I have some initial value, say n equal to 0, we know a 0 is 2 to the power 0 is 1. So, if this is given, then I can write the same sequence as say n plus 1 is to n. Where a 0 equal to 1, and this is defined for n greater than equal to or n greater than 0, that means n equal to 1, 2, 3 like that. Okay. Now, see, I tell that this is some explicit formula or some expression, explicit formula for representing a sequence of power of 2, but this is same if I write n plus 1 equal to 2n. Now, how recursion we have defined? That it is the process of defining itself. That means, only as if the next term n plus 1 we are getting from n, and we are writing that as a formula. So, if we remember mathematical induction, this is very similar to that thing, because induction also we have tried how one particular term can be represented using the previous terms, either one term or some previous few terms. So, this induction and recursion, that has a relationship, and that we will explain now. So, when we define a sequence recursively, so we write the basic thing that when we define a sequence recursively, the most important thing is that we have to find out, or we have to specify that how one particular term, how terms are defined from the previous terms. And see, this is same as that of what is we have called the mathematical induction, also we have used. So, to prove, normally we use mathematical induction for this recursive definitions of a sequence. Now, for sets, this is for sequences. So, if we define sets recursively, recursive definition of set. here also see we need some initial element of a set, and then we give a relation that how other elements of the set can be added or how they are related, and in that way we can generate the full set. So, we can write that we can define a set recursively by specifying some initial element and then provide a rule and for constructing the other elements of the set. And this rule, actually this rule must be, or some recursive way we can define. So, we can define recursively. You can this write rule for constructing a set recursively. Now, here also to prove the recursive definition of set, we use structural induction. Since this is a construction of the set, so we use structural induction. I give one example. Say as if one element 5 is there. So, I get one element A is 5 in a set 5 is one element in a set S. So, initially as if my S I consider that 5. We can think as if this is my basis step. If I compare from the mathematical induction, as if I can think that this is the basis step for, if I consider my S is, say S is A0, A1, A2, like these are the elements, then I can think that basis step as if the for A0 equal to 5. Now, we told that one rule recursively I can tell some rule. Very simple rule if I consider. What is that recursive rule? That recursive rule is, I can tell that recursive rule that each element is again we get the new element by adding 3 from the with the previous elements. So, as if the next element, recursive rule is the each element, or we get the next element, we get a new element by adding with the previous element. So, what is my A1? So, I get A1 is 5 plus 3, because A0 was 5, since the first element was defined, A0 was 5. So, I get the next element of the set is 8 plus 3 is 11. Next element I got, always with the previous element I add, and this is I am telling that recursively I get. That means, I can write some n plus 1th element I can get with adding 3 with the previous element. So, finally, I got my set as if I start with 5, then 8, then 11, 14, like that. It will get in this way. Now, obviously, I could start from a empty set, that then in that case it will be a if I would start with the empty set, that means if my if we start and we will get the same thing. So, I started with as if this is my initial element, or I could start with an empty set. We get the same set if but rules will be different. We start with, if we start with M set, our rule may be we give the same set with different rule. Okay. We get a different set of elements. If different rule is different recursive rule we use. Okay. Now, we see recursive functions. because that is most important, that we can define the recursively defined functions. Now, here always we have two steps. When we define recursive function, we have two steps. And this is very similar to mathematical induction. We give a basis step where we specify the value of the function, say I am considering at 0, then the recursively defined function must be must have some well defined domain. Since it is a function, the domain must be well defined, and say here I am considering the domain is set of non-negative integers. So, I am considering as if 0 at 0 I am specify the value. Okay. Now, the recursive step. Now, I have recursive step. This is very similar to our inductive step, that we give a rule, to define the function with the set of non-negative integers as the domain. So, my function is such, or my rule is recursive rule is such, it should not violate the domain that we have defined in the problem. As its domain. This is very important thing and we must remember. We take a very simple example of recursively defined function. Say basis step. So, we take simple say f0 equal to 2. Here also I am considering for this example the domain is set of non-negative integers. So, f0 equal to 2, and the rule, the inductive or recursive step, say we define something f of n plus 1 is something 3 of f n plus 4. Okay. So, now we can find f of 1, f of 2 like f 3, f 4 and so on. So, up to this. So, how recursively we can do this function? We can define. So, f 1 is, we can use the relation that say this is my basis step and this is my recursive step. So, f 1 is 3 f 0 plus 4, this is equal to 3 into 2 plus 4 equal to 10. Similarly, what is f 2? f 2 is 3 f 1 plus 4 is 3 into 10 plus 4. Similarly, I can do f of 3 is f 2 plus 4 is 3 into 34 plus 2 is 104. Then f 4 is 3 into f 3 plus 4 is 3 into 1, oh sorry, this should be 4 not 2. Because my recursive step is 3 f n plus 4. So, it will be 6. So, we recursively the definition that we have given, that it is defined by itself. Now, we see that every previous term, that means, if the function, the same function we are using only for the previous term, and this is very similar to our mathematical induction. Now, we see that very simple example that all of we know that factorial n, how to compute factorial n. So, another example we see, so, recursive definition of factorial n. We know that n factorial is n into n minus 1, n minus 2 is 3 to 1. So, this is my explicit formula. This is my explicit formula for factorial n. Now, we can easily define this thing, that n factorial is n into n minus 1 factorial. So, now if I define a function that say fact, that fact n is nothing but n factorial. So, I can write this thing as fact n equal to n into fact n minus 1. See that same function only with different arguments, that is used to define a recursive function, and this concept is actually our how recursively defined function we use here. So, this is the concept of, or this is the way we define the recursive function. And in computer programming, this is a very important role. We will read in the next class, there are many examples or many problems that a much easier way we can define with recursion, and sometimes when we write programs, the computer programs, then recursion has very important role. We can very easily write recursive program rather than our iterative program. That we will see in the next classes.